All right. Good night, everyone. Greetings. Good evening.
Good evening, sir.
All right. Good evening, Abigail. Good evening, Samantha.
Evening, sir.
Good evening, everybody. Good evening, Nisha.
Yes,
Good
sir.
evening, sir.
All right. Hello, Nisha. All right. Good. We are back. Happy to see all of you again. Hope everybody is in. Everybody is okay. Everybody is all right. Health wise, happy to be back here again with you another week. So let's get into it. Couple of updates before we proceed. Effective Monday, I'll be changing the link. I see some of you guys are already texting me your class pass and bank voucher payment slip. So as soon as I've created the link, I'll send it to you. But remember, effective immediately. Effective Monday, I will be changing the code to a new class link. Right? The school asked me to do it from the 5th, but I gave you guys an additional week, so you can get that sorted out on Monday. So on Monday, I will be you'll get a message from me from those who send me the picture of their class pass, the blue class pass that you're supposed to get, or your bank voucher payment slip. Okay, all right, that's one. Two, I know that some of you guys have recently sent me some SBAs. But remember, guys, that if you send me an SBA just now, you can't get a response right away. You know? Okay, you would have been sending very late, so you'd have been joining a queue of quite a few persons. Everybody's sending me the SBA all at once. So it's becoming very pressuring, which is something I was trying to avoid. But everybody's sending me the SB, so some of you guys are the pressure is going to be returned. The pressure is going to be returned because you're applying the pressure to me. So you're going to be joining a queue of other persons who have been waiting. So you may get back a SBA response very late, even closer to the deadline than expected. All right, Nisha. Yes, I remember you had sent me an SB as well, about a 2 week ago. I'll get your message got pushed down, but I'll try to jump on it tonight. By morning, you'll get a response. Okay. All right. Yeah, and I'm wrapping up the poster for the marathon. Guys, just a reminder that the marathon starts on March the 29th. Well, for the persons who are online, remember in that class, guys, we'll be going through the whole entire syllabus. Once again, a whole entire past paper. So as soon as the poster is posted, sometime this week you should see it. We'll be starting on March the 28th. The class is from 9 a.m. in the morning until 4 p.m. in the evening online for those who wish to join online, okay? We'll let you know the process of how the payment and stuff goes. You'll see everything on the poster when it's posted. I just have a few more changes to make to the poster and then you'll see everything. All right. So as long as you wish to be a part of the preparation for exam, everybody is welcome. Anybody is welcome. I can invite other persons as well to join the class. Okay. All right. So that is out of the way. Let's proceed. Miss Gentles, where are we today? Is Zahina here? Z, are you here?
Yes, sir, I'm here.
Okay.
Oh, sorry, we were at trigonometry.
Okay. Did we go through sine, cosine, tangent already?
Yes, sir.
Yes, sir.
We did sine, cosine, and tangent.
We do any application questions?
Right.
We only go through like one single shape, like one single diagram. We never go through like double shapes.
We went through a diagram that had all three.
So we never go through a shape that looks like this, or anything that looks like.
Yes, we did one of that.
Okay. All right. I think I sent one in the Google Classroom. Oh, were you guys able to view the worksheet and view the solution?
Yes, sir.
All right, so I can just take our time and try to work some of those questions. All right, I'm gonna do one. Hopefully I can find it. Oh Lord. Don't think I have a copy with me. Don't have a copy with me. I don't have a copy with me. Hold on, let me see if I can. Give me a second, guys. Let me grab one from the Google Classroom here. As I'm gonna go through the one. I'm gonna go through the one that was on the worksheet.
Okay, sir.
Related to tonight's class. Just that question I want to go through. Online 7 o'clock. All right. End of month January solution. Pre-mock exam paper solution. Hopefully this is it. Might be this one. Okay, so it's the other one. All right, so the question that was given to you was this one here. All right, so we were given this shape here. Something like that. And we were told that this angle is 38. We were also told that this side is 18 meters. We were told that this side is 9.7 meters. And right here is 90. And this angle right here is empty, that is P. This is G. This is R. All right, and we were asked 3 questions totaling 6 marks. So on the question paper, if you guys have access to your Google Classroom, you can see the question. It says a vertical flagpole FP. Oh, this is F right here. So it says a vertical flagpole FP stands on a horizontal ground GFR. Okay. And is held by 2 ropes, PG and PR. All right. As shown in the diagram below. We are to use the dimensions as shown on the diagram to calculate the flagpole, the length of the rope PR, and we are to calculate the size of the angle created by the 2 ropes, PG and PR. All right, so let's interpret this. So we are told that this thing right here is a flagpole. All right. And we're also told that these 2 things right here is a rope. So this is a rope and this is a rope. All right, and we were also told that this thing down here is a horizontal ground. So the blue colors represent the rope, the red represents the flagpole, and the green represents the ground. All right, cool. We were told that one of the rope is 18 and a part of the ground is 9.7. And we were told that the angle between this rope and the ground is 38 degrees. So we are asked to calculate the height of the flagpole. Well, you can obviously see that we're looking for this red line here. So you're looking to find the red line. And based on the 2 classes that we have had thus far in trigonometry, we realize here that we can either use Pythagoras theorem or one of the ratio. And last week we went and we looked at how to use the ratio. Remember, to use Pythagoras theorem, you have to have 2 sides of the same shape. So we have 2 sides. We have the 18 here, and we have the 9.7, but they're not on the same triangle. So Pythagoras theorem has been eliminated. That means we have to use a trig ratio. Now, if you recall that this is the angle, so it makes this side the opposite, and the 18 that was given is obviously our hypotenuse because it is facing the 90-degree angle. So if we can use sine, because sine is O and H, we know that sine theta is equal to opposite over hyp. So sine of 38 is equal to the opposite, which is the flagpole, FP, divided by the hypotenuse, which is 18. So seeing that the unknown is at the top, as discussed last week, FP works out nicely to be 18 times the sine of 38. And I've done this question a couple times today, and I think I did it on Saturday. I remember that the answer is 11.1. All right. So yeah, it was 11.05 rounded off to 11.1, or it's 11.08, something like that. Rounded off to one decimal place, so we get 11.1. Everybody clear with that? Everybody good with that one? Everybody's good with that one?
Yes, sir.
Yes, sir.
Good, good, good. All right, next one says that we should find the length of PR. So we're looking for this length right here, PR, that length. So now if you notice carefully here now that we have 11.1, we can take our answer that we just got here and put 11.1 here. Let's erase this and this. So I can take my 11.1 and put it right here. All right, so now you notice now that I have two sides now to find the third. So that's Pythagoras theorem. So c squared is equal to a squared plus b squared. So c squared is equal to a squared plus b squared. All right, and in this case now, c has to be the hypotenuse as we discussed. Or I'm not sure if I thought, I'm not sure, I think you're the group. I think you're the group that I showed 8 squared is equal to O squared. I think you're the
Yes,
group.
sir.
Yes,
Sir.
sir.
That's what you gave us.
Okay, right. It's the same thing, but it's just that I
It's the
thought you
same
guys
thing.
from. Yeah.
Yeah. Because I was wondering to where this C that came from.
Yeah, man. And the same thing, man. The C is just the hypotenuse. So it is O squared
Okay.
plus A squared. Same thing. All right, so the hypotenuse squared is going to be PR squared. And that's going to be equal to 11.1 squared plus 9.7 squared. And when we work this out, I think we're going to get 200, was it 250 point something? Confirm that, please. It's 250 point something, I think, if I remember correctly. So much? No, man, 200 and something, but I'm 250.
It's 217.3.
217.3. So therefore, PR is going to be equal to the square root of 217.3. And if I remember correctly, this is about 14 point something. 14.5, is it?
7.
14.7 centimeter. And that would be that side. So this side then will work out to be 14.7 centimeter. Simonia, you want to write on my board?
Sorry, sir.
It's okay there. All right, so it's 14.7. So this side here is 14.7 meters. And what I love, the beautiful part about this question, how it's set up, is that the third question now, which then asks us to calculate the size of the angle created by the two rope. So as you can see here, this rope right here, let me grab the blue marker. So this rope right here, this rope over here, and this rope over here, basically create an angle up here. Now look at the red line. Notice that the red line cuts the angle into two pieces, not two equal pieces, you know. Two pieces. There's no evidence to say that the two angles are equal. So you cannot say this angle is equal to this one. There's no evidence to say that. But we know they are cut into two pieces. Now we can find this piece over here very easily. Because notice that we have 38 right here and we have 90. And angles in a triangle measure 180. So you could say 180 minus 90 plus 38. And that's 180 minus 128. And that works out nice to be 52 degrees. Right? So that's that piece over there. Now this piece over here now, that piece over there now, notice that I have all three sides over here. So we have 14.7, 11.1, 9.7. We could use any one of the ratio. Now, even if you make a mistake and think you use the wrong ratio, you're still going to get the right answer. So to find this piece right here, we can use either sine, cos, and tan. So I'm going to use sine again. In fact, I'm just going to use tan. So tan theta So tan theta is equal to opposite over adjacent. So in this case, I'm going to, the angle I'm looking for is theta, so I don't know what it is. But I know that the opposite, because I'm looking for this angle, ladies and gentlemen, this is the angle I'm looking for, and I'm using tan, then 9.7 becomes my opposite. Once you're using tan, the angle that you're looking for, the side that is in front of that angle that you're looking for has to be opposite. And the adjacent in this case is going to be 11.1. All right, when you divide those two, can somebody tell me what you get when you divide those two, please? You're going to get 0 point something.
Zero 0.87.
0.87.
Yes, sir.
Thank you very much. And then now to find the angle, as we stated last week, we use shift tan and press the number 0.87. Confirm if you got 41 degrees.
Yes, sir. 41.
Yes, sir.
You guys can try using sine or cos and you'll end up with the same answer. All right, so that was the question that, yeah. Now, as I said, guys, look into the Google Classroom. I've uploaded the worksheet and I've also uploaded the step-by-step solution to how you should actually, how the result paper should look like on an exam paper, right? So I've laid out nicely. I'm looking at it right now. It don't look too bad. So I did everything step by step, line by line. I did every question. The graph is kind of blurry still because of the scanning. It scanned the graph and removed the color. So you might have to zoom up, all right? And then you'll realize here that I work it out. And you can see on the actual exam paper, I use cos and I got the 41 same way. All right, so check it out and just work assiduously towards that. However, though, remember, guys, I'm going to give you a mock exam in April. It's an official exam, right? So you guys can know where you're at. I'm going to be putting it online as well. Okay, but this time we're going to come to class and leave you, let you work it, and then upload it for me to see. So we need to know exactly where we are approximately 3 weeks before the exam. So mid-April, I think it's going to be the second Wednesday in April. I'm going to drop the test based on what you guys have been taught so far. All right. So we need to know exactly where we're at, what we need to fix, because in those last 3 weeks, we're moving fast. We're not rushing, but we're moving fast to make sure so we have an idea of, what we need to do to fix where and when, so we can put ourselves in a position to do well. Okay? All right. So tonight we're moving on to phase number 2. So for the last 2 classes, we've been focusing on the right angle triangle, as you can see. We've looked at the Pythagoras theorem, and we've looked at the trig ratio. So now we're going to move to this part of it now. Sine and cosine rule. Sine and the cosine rule. So cosine and sine rule. All right, so these two guys here, they also work together. Just like how Pythagoras theorem and the trig ratio work together, they work in the department of the right angle triangle. These two boys right here, they also work together. They serve the same purpose, right? So what are their purposes? Their purpose is similar to that of the trig ratio. Their purpose is to find the length. So their purpose is to determine the length of an unknown side. Or you see, you learned about cosine today at class, or you watch it online. Okay, so you're getting another of those. That's good. So the purpose of this is to determine the length of an unknown side and the size of unknown angles. But here's the catch now. The catch is just because we were finding lengths of unknown sides and unknown angles when we were using the trig ratio and the Pythagoras theorem. The difference between the cosine rule and the sine rule is that these two boys operate under this triangle right here. So it operates under the non-right angled triangle. So basically, majority of the time, this formula is applied in the scalene triangle, to be very specific. So majority of the time, you're going to find that this shape operates under the scalene triangle. Any triangle that doesn't have the box in it, this formula will be quite helpful. So most of the time, it's going to be the scalene. It can be applied in the isosceles as well, but it's very rare that you see an isosceles triangle involving these types of questions. Majority of the time, it's applied in the scalene triangle. All right, so what is the cosine rule? So we're looking for the formula. Now, I'm going to stop sharing my screen for a second. My whiteboard for a second, a sec. And I'm going to share my screen instead. So we can jump on a past paper and I can show you where the cosine rule is located. I want you guys to see that this thing comes on the actual so the formula I'm going to show you here is not something you have to really hurt your head up to try to study. Just make sure you know how and when to use it. Assuming that you guys are seeing my screen. You guys are seeing my screen, right?
Yes, sir.
Yes, sir.
Sir.
Right, so I'm pulling up last year's paper. And as you can see here on the screen, this is the instruction that comes at the front. And then here's your formulas. Look at the bottom, guys. So that sine rule, cosine rule. And there's the formula right there in front of you, right there. So the issue right off the bat here isn't really about the formula itself. The issue is how to use it, where to use it, when to use it, and how do you apply it. That's going to be objectives. So right away you can see there, guys, that's the formula that we're going to be discussing today in this class. All the different scenarios that it comes around. All right. Oh yes, and before I actually come out the paper, let me just scroll down to the back end. Let me show you where you find this question. So you find this question all the way around at the back. So look at this, question 10. That is vectors and matrices. Go back all the way up here. This is where you find it, in that shape right here. This is bearings. So this is where you apply the cosine and the sine rule majority of the time. All right, you find it here in this section. At question number 9A, as you can see here. So that's a bearing. So when we get here, you'll understand a bit more. All right, and if you look at another past paper, there's another random one. Click on another random one. If you go back again to question 9, you see one next one there? That's the cosine rule again. So we're going to look at this scenario. In a second, you're going to see me do an example like this one that you're seeing here on the screen with the 120, the 150, and the 180. And you're going to see that the cosine is worth, how much marks is it worth? 3 marks right there. So we're going to look at how to apply it. All right? Let's get back into that. All right, so as you would have seen here on the screen, we have different variations to it, right? But what you would have seen here is that the cosine rule is, I use it in this method, c squared is equal to a squared plus b squared minus 2ab times the cosine of the angle. All right, so that's the formula for the cosine rule. Let's put a little box around that. So that's the cosine rule, guys. So here are the two scenarios that they are applied in. Scenario number 1. So scenario number 1.
Sir, what's that you have? C square equal, or is it A
Yeah, c
squared?
squared equal, say c
Okay.
squared equal a squared plus b squared. So scenario number 1. I'm going to draw the diagram first so you can pick up on the clue. So scenario number 1. So the shape must look like this. It must be a triangle, but you must be given one side, or it must be given 2 sides, and you must also be given the angle between the 2 sides. That's scenario number 1. So writing the information here, must be given 2 sides and the angle between. I'm emphasizing on the word between because I like to play games, you know. They love to give you a shape with 2 sides and give you an angle, and then them trick you, because if I don't emphasize on the word between, people will run away with the idea that I said 2 sides and an angle. It has to be 2 sides and the angle between the 2 sides. In the textbooks, which I strongly recommend that you don't really go into the textbooks and do these things, because the textbooks give so much mathematical definition. So in the textbooks, what they'll say is that you must be given 2 sides and the included angle. That's what they call it, included angle. So for those who don't know what included angle means, included angle is the angle that's between the 2 sides. Or it's the angle that is made by the 2 sides. Okay? All right, lovely. So once you have that situation, then you can apply the cosine rule. And remember that this side over here, This side here is C. So please note that C is actually the side that is in front of the angle you're trying to find. So is either C becomes the unknown side, or C is the side that faces the unknown angle. Please note, I said C can either be the unknown side, because there's going to be a scenario. The next scenario that I'm going to show you is a scenario where C, you don't have an unknown side. So C can either be the unknown side, or in some instances, C will end up being the side that faces the unknown angle. The side that faces the unknown angle.
So what if the angle is given? Is it C just the same?
Yes.
Or it's only if it's unknown? Okay.
No. So if the angle is given, C is in front of it.
Okay.
If the angle is not given, C is still in front of it. All right, so let's look at an example. So here's a scenario. And we are told that this side is 9 centimeter and this side is 13 centimeter. And we have placed an angle right between here. We're going to call this angle 85 degrees. All right. And then we're told we're going to call this side A. Sorry, let's use a different color. This shape is called A, B, C. And the question proceeds to say, determine the length of BC. 3 points. So determine the length of BC. So in this case here, we're going to go ahead and we're going to apply the cosine rule. C squared is equal to A squared plus B squared minus 2AB times the cosine of theta. All right. So in this case here now, C is going to be this side because C is in front of the angle given, always. So C in this case is going to be BC squared. And that's going to be equal to 9 squared plus 13 squared minus 2 times 9 times 13 times the cosine of 85 degrees. All right. I need my calculator peeps to help me out now. 9 squared plus 13 squared, you can do all of that one time. So you can go ahead and do these two and then do all of that one time. So we can cut the working out chart. So 9 squared plus 13 squared, I believe that is 169 plus 81.
Sir, 9 square plus 13 square is 250.
Thank you very much. And go ahead and multiply the negative Negative 2 times 9 times 13 times the cosine of 85. All of that one time and cut the working out short.
$20.4 got.
All right, go ahead and subtract those two, please. So BC squared is equal to
230.
or 229.6. Which one?
No man, we get 230. 250 minus. Oh, yeah.
59.6.
True.
All right, so therefore BC works out to be the square root of that thing. And so BC is equal to
15.1.
and that's it. So the length of this side here is 15.1.
Right hand square after 2.
All right, yeah, man. 15.2, 15.1.
Yes,
Right?
yes, yes.
Right, and that's it. That's how you apply the cosine rule to that shape. So I guarantee you now, if I pull up a random past paper, watch. I'm gonna show you. All right, so I'm gonna unshare the screen here. So I'm gonna ask you guys to just anybody who say it, just pick a year between 2020 and 2021 and tell me the month, January or May, and watch what happens. Pick a year and pick a month, January or May.
May 2021.
All right, thank you. So she said May 2021. When if I think maybe that's the year COVID struck, or COVID was ending. Let us see if it's there. So she said May 2021. Let's see. Let's see here, May 2021. And let us see what happens. A bit of we find one question. All right, so May 2021. All right, so that year we only did May 2021. She's right. So this must be it then. Here is your paper. May 2021. That's it. The exam was May 12th, which was the exact date that we are doing our exam this year. Oi. I wonder if I sign this here. The exact day when we're doing our exam, is this exact day of the paper that she picked. All right, let us scroll down and see what happens. Let's see if we can find one. Question 5. Let's see if we can spot it. Can we find one, guys? Oh dear, look at that. Look at that. Yeah, but it's a bearing. It comes in the form of bearings. So something is there, but we're not ready to do this yet. Pick another year. We come close. Pick another year.
May 2023.
May 2023. All right, here it is. May 2023. What was the date? When I see a date on it, they never give you the exact date. So May 2023. All right, let's scroll down and see if we can find something. It's a bit early for us to be looking at past papers, but let us see. Here it comes. Here it comes. Oh. So we're going to this scenario. So we're going to hold on then, because look like we're not finding any as yet. So we're going to hold on to this question. All right, so I'm going to explain the second scenario. I'm going to come back to that shortly. So I guess because it's a bit too early for us to be doing any past papers yet. All right, so that was scenario number 1, ladies and gentlemen. Remember that when you have two sides and the angle between, you use the cosine rule. But here comes scenario number 2 now. This is another scenario in which cosine rule is applicable. So scenario number 2. So here's the diagram that matches it. Are there any questions, by the way, on the first one? No questions yet?
No.
No questions yet. So here is scenario number 2 now. So with scenario number 2 now, we must be given all 3 sides. So we must be given A, we must be given B, and we must be given C. Hold on, let me just use a different color ink and keep it the same. So here we must be given A, we must be given B, and we have to be given C so that we can find any one of these angles here. In this case, I would like to find this angle. So this must be given, this must be given as well, and that must be given to find any angle that we need to find. So watch this now. Quick question to you now. I'm trying to find this angle right here, question mark. Notice where C is in front of it. But my question to you now is, what if I didn't? Let me just erase all of these now. What if I wanted to find this angle instead? Where would I put C?
In front of the angle.
So this would be my C, and any one of these can be A and B. Similarly, what if I wanted to find this angle over here? Where would I put C?
In front.
All right,
of the
again.
angle. Yeah.
Right, correct. So this will be C, and any one of these can be A or B. So notice that C is following the angle that you're looking for. Because in this case, because none of the sides are unknown, you can't just get up and pick any random side for C where you feel like. C has to be very specific to where you're, what angle you're trying to find. So therefore, then in this case, because I'm trying to find this angle right here, because I'm trying to find that angle right there, then in this case, my diagram is going to be labeled like this. C, A, B. Anyone can be A or B, doesn't matter. All right? Now, since as we're on the topic of past paper, let us go back to that question that we saw earlier. So since as we're on that topic, let us go back to that question and take one from our past paper. There it is. You see the scenario? Somebody can read information at the top, please. Anyone can read.
The diagram below shows a triangular field LMP on horizontal ground. Calculate the value of angle MLP.
So MLP is the angle that is at L. Notice that L is in the center. So calculate the value of angle MLP. It means that you're looking for the angle. Well, obviously you're looking for this angle right here. Right up there. So that's the angle you're looking for. So if you notice that we have this side A, this side B, and now we have this 180 right here, which is going to be our C, because the 180 is in front of the angle right here that we're trying to look for. It's angle called MLP. All right, and how much marks is it worth, guys? 3. So you're seeing this, you're seeing the evidence of an actual question that is required of you. Okay, so let's draw it then. So it's 180, 120, and 150. Let's go back and draw that diagram. All right, so in this case then, we're going to go ahead and erase this. We're not going to draw the diagram exactly. We're just using the numbers that are there. So if I remember correctly, I believe this was 150. So we're not going to use 150. Them numbers are too big for now. So instead of using 150, we're going to use 15. Instead of using 180, we're going to use 18. Instead of using 120, we're going to use 12. So the numbers are smaller. All right, so this is 15 centimeter, 18 centimeter, and 12 centimeter. And so we are told, so this is L right here. This is, I think it was MLP or something like that, maybe the other side around. Doesn't matter, the angle is still right here. So this scenario here presents the use of the cosine rule. So here C squared is equal to A squared. So C squared is equal to A squared plus B squared minus 2AB times the cosine of theta. Now in this case, C is going to be 18 squared. And A is going to be, A or B can be 15 or 12, it doesn't matter. So I'm going to use 12 as A squared and 15 as B squared. And that's going to be 2 times 12 times 15. And then this time we're going to find the cosine of the angle. We don't know what the angle is, so there's nothing to cos. All right, so go ahead now, guys, and work out all of this one time. All of that one time. We don't need to waste time. Because remember, we're in the exam now. No one really cares about what you... If you want to work it out piece by piece, it's up to you. So if you want to work out this part and then that part, that's up to you. I would just strongly recommend that you get to work because we don't have the time to waste. You're in the exam, you want to do this question as fast as you can. So go ahead and just work out everything. Just type everything into the calculator all at once right here. 12 squared plus 15 squared minus 2 times 12 times 15. One time. So 12 squared plus 15 squared minus 2 times 12 times 15. What are we getting?
9.
9?
Yes, sir.
No, that can't write. Try
That's
again.
what I got, sir.
9?
Yeah.
I got
Yes, sir, I got
81.
9 as well.
Yeah, that's
Sir, I got 9 and I retype it and do it
Awesome.
over and I get
Yeah, do it
back
again.
9.
Sir, I got 81.
81.
Yes.
Oh, Jesus have mercy. Chai. Guys, I've just remembered, sorry. You can't work it all at once. You have to work out this part first and then this part after. Yeah, I just remembered. Because these three are tied together, that's why. My apologies. Yeah, you're right. So go ahead and work out this part first and then work out this part second.
The first part is 369.
yeah, correct.
369. So that's 369. And what's the second part? So now 360.
Yes, sir. Negative 360.
Correct. Times cos theta. All right, so here's why you can't subtract it. So the reason why we can't subtract it is because the 360 and the cos is tied together. You cannot take out the 360 off of the 369 and write it back on the cos. You can't subtract and multiply at the same time. So that's why that can't work. So in this case, what we're going to do is we're going to go ahead and bring the 369 over here. So we're going to transpose this over here. So we're going to end up with 324 minus 369. And that will give us negative 360. Negative 360 cos theta. So go ahead now and tell me what is 324 minus 369. Should be a negative number. Is it negative 45?
Correct.
Yes, sir.
Yes, sir.
Negative 45. And that's going to be equal to negative 360 cos theta. Now remember, we're looking for cos theta, you know. So we need to get rid of that 360 that's beside it. Considering that they're multiplying each other, the opposite of multiply is to divide. So we're going to end up with negative 45 divided by negative 360. And that should give us cos theta. So if I'm correct, I believe this is going to give us 0.125. Confirm, please.
Yeah,
Yes,
negative 0.
Positive. Because I 2 negative are divided.
It says negative.
It's negative.
Yeah.
Negative 45 divided by negative 360.
0.125.
So it's positive 0.125. Correct?
No.
Type in negative 45 divided by negative 360.
Yeah, I never put negative 360. That's why.
Right. Careful. It's going to give you a bigger angle. All right. So now, as we did last class, nothing to change to find theta. Theta is going to be equal to the cosine inverse of 0.125. So you press shift or you press cos, and then you press equal, and then you should get the angle.
I got 82.
Thank you. 82 degree. That's it.
82.
82.
I round it out to 83.
82 point how much I get?
0.8.
Okay, so 83 is fine. 82 won't be wrong, you know. But, you know, it's better to be accurate. So 83 degrees. So guys, you see, even if I had on the zeros here, 120, 150, 180, these numbers, these 324, they would have just been bigger. It would have been 32,400, 36,900, 36,000. It has still boiled on back to 83. So if no matter what numbers are there, the angle still going to boil down to an angle that is less than 90. All right, and that is how you calculate using the cosine rule. And if you wish to get even more examples, like I said, I think Miss Gentles may have sent my trig playlist in the group. I think there's a titled video there about cosine rule. So you always can check it out if you need extra, if you want to go back through. So you can either watch back the recording, or you can watch one of the made videos that I did on my channel. You can watch that if you want to get to tie it up a little bit. All right, so that's the cosine rule. Those are the two scenarios. So keep your eyes open for when you have two sides and the angle between, or you end up with three sides and wanting to find an angle. All right, these things pop up everywhere and anywhere. Don't just think they're going to pop up in trig. They're going to pop up in area of triangles and all sort of something. So keep your eyes open for it. I'll constantly remind you, though, you're going to see plenty of examples of these coming up in the next month or so. All right, now here's the fun part for me now. All right, and when you go on YouTube, and I tell you, when you go on YouTube, even if you watch it on my channel, I along with the other person, them, when we talk or we explain this thing, we confuse people. Yeah, it's not something that we try to intentionally do, but because of how we are taught and how we were taught to teach you. But we have to find one ways to go around this. So I found out some years ago that the sine rule and the cosine rule, they work hand in hand. And what I got to realize is that there are some questions where the cosine rule is not applicable. So what do I do when I can't use the cosine rule? Well, the two of them work in one department. And trigonometry's sine and cosine rule is like being in a relationship. When one partner can't handle the problem, the other partner fesses up. So if one can't pay the bills this week, the other one pay the bill. If one cannot do this, the other one does it. So they work hand in hand. So I'm going to put a scenario on the screen, right? I'm going to draw a shape. And then you're going to tell me, based on what you've learned thus far, do you think cosine rule can be applied? Because the moment cosine rule can be applied, I'm not going to think about trying to use another formula. Because as you can see, using the cosine rule isn't as difficult as persons make it out to be. So I'm going to give you a scenario here, and then you tell me if it can be used, and if your answer is yes, tell me how you know. But if your answer is no, tell me also how you know. So here's the scenario. Seven centimeter, 34 degree. X centimeter, $75. So the instruction is find the side, find the length, find the length of X. That's the instruction. So, question to the class: Can cosine rule be applied?
No, sir.
What's the main reason why you say it can't be applied?
Because cosine is applied when the angle is between two given sides.
Do you have two sides?
But it's not given. It's not between the two given sides.
So the question is, were you given two sides?
Yes.
Which two sides were you given?
Well, we're only given one side.
Correct.
One is X. So
right. So you weren't given two sides. You
we
were
weren't
only
given two
one.
sides. Yes.
So you were given one side and you were asked to find the other. But based on the examples I just gave you earlier, cosine rule, you must be given two sides in order to apply it. Therefore, what can we say about the cosine rule here? It is not applicable. So who comes to our rescue? Cosine rule says, hey, I can't solve this problem, there's not enough information. Sine rule will jump up and say, I can help. So here comes sine rule. So the reason why I don't go through the whole, because when you look in the textbooks and you watch some other videos and stuff, when they explain it, it can be a little confusing. Why? I'm speaking from a student's point of view. If you don't understand what or how to apply the trig ratios or the trig rules, when they explain to you, you might get it. Some persons might get it, some persons might not. My best way of explaining this is that you use the sine rule whenever the cosine rule is not applicable. So what is the sine rule? Once again, let us unshare the screen, the whiteboard here. Let us go back to see what it looks like on the paper. All right. Let's go back to our formula sheet. If you go back to our formula sheet here, look at the bottom there. See that? Sine rule, scroll over. Here we have it. So small a over the sine of big A, small b over the sine of big B equals small c over the sine of big C. Obviously, we cannot compare three things simultaneously. So what we do as math teachers is that we just normally use the first two, right? You can compare any one of them. You can compare A with C, B with C, or A with B. We just normally stick with A with B, all right? We just ignore the C. Okay, you cannot compare three things simultaneously. You have to compare the first two and then compare it with the third, but only two things at the same time. So you're seeing it here on your formula sheet at the bottom. The challenge with this is, can students know how to apply it? All right. Let's go back here. So here's the diagram that we're looking at then to apply the cosine. So I'm going to use a green color now and show you what's going on. And listen to this one carefully, guys. All right. Now, when to use the sine rule? Remember, let me just write out the formula here. The formula says that it is small a over the sine of capital A, and that's going to be equal to small b over the sine of capital B. So what is A, what is B? I'm going to use the green color now to highlight it. Now, because we know that these small letters up here, they represent the length. And these big angles, these big letters down here represent the angles. Here's what we're going to do, guys. We're going to pick a side and call it A. In this case, you can't go wrong. There's nothing you can do to go wrong. Pick a side and call it A. In front of it, you're going to find capital A. Obviously, you're going to pick the next side and make it B. And in front of it, you're going to find big B. That's how it works. So, sir, what if I had made a mistake? Because me know we're not going to try to ask me, say. You're going to be like, sir, what if I had said, this is A, and that's capital A, and this is B, and that's capital B? Would I have gotten it wrong? You would have still gotten it right. And then, of course, you know, you have the student there that's going to make the odd mistake of saying, this is A, and that's capital A. That wouldn't make no sense because you don't want to find that side, and guess what? You don't even have the angle in front of it. So it doesn't make no sense you even deal with that side. That's the side that we ignore. That's the C over C. That's the C over sine big C. So try to give your sides a name based on the information that's given to you. So again, what I do here is that I pick a side, I just call it A. I cannot go wrong. No matter what I do, I can't get it wrong. So I pick a side, I call it A, and then right in front of small a, I can label the angle big A. And then I pick the next. I wouldn't pick this side, guys, because I don't have the angle in front of it. I have nothing there to support me. I have a stick. So I don't have this side. I don't have it, regardless if I don't have it, but may have something in front of it, which is the big B. So that's how it works. Any questions? Okay. All right, so let's apply it then. So now we're going to go ahead and just erase this here. And let's plug the numbers in now. So based on what we've labeled with the green, small a is 7. And the angle in front of the side that is 7 is 34. So it becomes the sine of 34. Small b is x. And the angle in front of x is 75. So it becomes the sine of 75. Now look carefully on the left. Do you then realize that we can divide 7 by sine of 34? So go ahead and press 7 divided by sine of 34.
$12.5.
Pardon me?
0.5.
0.5 or 12.5?
12.5.
Or 12.5. Okay, thank you. So that's 12.5. And that's equal to x over the sine of 75. And if you notice that this is sort of looking like what we did earlier. Remember we spoke about that last class. When the unknown is at the top, what do? Multiply. When the unknown is at the top, we multiply. So x then works out to be 12.5 times the sine of 45. Sine of 75, pardon me. So that works out to be
12.
Pardon me?
12.
Exactly 12? Okay.
12.0. 12.
Oh, yeah, so 12 centimeters. Right? And that's it. So therefore, this side down here is equal to 12. And that's it. All right. Now I'm going to try to trick you. I'm going to try to trick you. Any questions on that before I scroll up?
No, sir.
Remember, ladies and gentlemen, that there is a button right here. Look right here. So up here you will see to your top left, there's 3 lines that looks like this. 3 lines that looks like this. You can click on that and export the whiteboard before I close the class. And you can write off your notes after that. Okay? Because while you're writing your notes, you can write your notes and study at the same time. All right. So nothing so far. Okay, cool. Nice. Lovely. Now, I'm going to try to trick you. And be careful where your response be. Remember, me I tell you, I try trick you now. So look out for the trick. I'm not telling you when the trick is coming. It could be now, it could be within the working out. So keep your eyes open for the trick. So the question is going to be, can the cosine rule be applied? And the answer can be yes or no, but it has to be support. You have to tell me why you say yes or why you say no. All right. So the question is, can the cosine rule be applied? Oh, sorry. The question is to find the angle. So find theta. Can the cosine rule be applied?
No, sorry, it can't.
Why do you think so?
Because
Yes,
just
sir.
like the other one before,
Go ahead and tell me. Yeah. So you said what?
the angle is not between the two.
Very good. Very good. Very good. That's it. Right. So even though you have 2 sides, if you don't so I emphasize on the fact that cosine rule can only be applied when you have 2 sides. And then I toned down my voice when I said the included angle. Because I was trying to set this up from early, hoping that I would catch you. So even though you're seeing the 2 sides, you notice that the angle given is not between. Yeah. So cosine rule cannot be applied. So you have to keep your eyes open for that. All right. So therefore, in this case, since cosine rule cannot be applied, you don't have a choice but to use the sine rule. So then we end up with small a over the sine of capital A is equal to small b over the sine of capital B. So again, just like before, pick a side, call it A, look in front of it, you find big A. I'm going to pick this side, I'm going to call it A. In front of it, I'll find big A. Right, directly in front of it. Then I'm going to pick B, and then I'm going to call this angle up here B. There's no point in me picking this angle and picking this side because I'm going to have them. They're not facing each other. I have nothing. I don't want it, and I don't have anything supporting it. All right? Okay, lovely. All right, so therefore, let's go ahead and punch in those numbers. So we end up with 4. Oops, sorry. 4 over the sine of the angle in front of 4, which is theta. And then we have 13 over the sine of the angle in front of 13, which in this case is 100. Now look on the right. Do you notice I can divide 13 by sine 100? So go ahead and do that then. I can't say 4 divided by sine theta because I don't know what theta is. But I know I can find what is 13 divided by sine of 100.
So that's 13.
13 divided by the sine of 100 is 13?
Yes, sir.
Okay, that's fine. No
13.
problem. No problem. So 13 divided by the sine of 100 is 13, she says. But notice the difference between this question and the previous one. If I go back up here, what did I say happens up here? Up here, we said that the unknown was at the top. So what did we do? We multiplied. But if we go back down here, so you'll realize that I stated that now the unknown, what we're looking for, is actually in the bottom. So this time we go swap. Just like we did the last class, the 13 comes down here and the sine theta goes up here. That's the legal shortcut. So therefore we end up with 4 over 13 is equal to the sine of theta. What's 4 divided by sine 13? Sorry, what's 4 divided by 13?
.3.
Exactly, or some more decimals.
0.31.
One more.
Yeah. That's 0.07.
4 divided by 13, and it's 3 digits after the point.
0.307.
That more want.
No, it would be 8.
Okay, round up 308.
6 is behind.
Yes.
6 is behind. So
308.
Right, equals sine theta. So now we want theta. We know say theta got equal to sine inverse. When you're finding the angle, remember you find the inverse. Now, would you have gotten it wrong if you said sine inverse of 0.3, 0.31, 0.307, 0.308? It's just that the more decimal places I have is the more accurate my answer is going to be. But you're not going to be wrong. If you find sine inverse of 0.3, you're going to get an answer relatively close to what we're going to get now. So how much did you get when you press shift sine 0.308?
17.9.
This is a very small angle. 17 point.
9.
So round it up to about 18.
Right, you can.
Right. Go ahead and go ahead and do sine inverse of 0.3. Just that alone. What did you get?
$17.5.
Round it up. What you get? 18. So with more decimal places, your answer becomes more precise. That's what we're trying to say. All right. Any questions on that? So that is basically what we call the trig rules, sine and cosine rule, and all the scenarios that surrounds it. All right. Now, what I want to do for me is, so in our next class, we're going to be looking at the topic of bearings. And so let me just write it here. Bearings. That's what comes up next. Bearings. And in bearings is basically the section of trig, what we call is the application of trigonometry. So bearings is the application of trigonometry. So all the rules that you've learned thus far, trig ratio, Pythagoras theorem, sine rule, cosine rule, in trigonometry, based on the diagram that's drawn, then these rules are going to play an important role in you getting to your answer. So bearings is the application of the mathematics in real life. So that's what we're going to be doing next week, Monday. Monday night, the application of trig. So Ms. Gentles, make a note of that for me, please. We're going to be doing the application of bearings. All right. Some of you guys, well, maybe 2 or 3 persons would have seen me touch base on this on Saturdays. But I'm sure that you guys are going to get the clarity you need when we start it. So you can be functional with everybody else. All right. We don't have much time left, but I still wanted to show you a bearings question to see what it looks like. So I wanted to see the title, the actual title here. Give me a sec. So I wanted to see the word bearings on a past paper. All right. So if you go back to our, right, and if you're gonna look at bearings come every year. Ain't nothing funny about it. All right. So pick a year between 2020 and 2010.
2015.
Okay, thank you. January or May?
January.
Okay, there we go. Loading. All right. So somebody type the paper by hand. Pick a different year because the paper that I'm seeing, right, somebody typed it. I don't trust when they type it. Let's pick the May, June.
2018.
Oh no, we're going to work with, oh, sorry, gone already. All right, so I'm on 2014. I'm going to scroll down all the way here. And if I scroll all the way down to, there it is. Look at that, guys. How do you find PR? What rule would you use to find PR? What rule would be applied to find the length of PR?
Pythagoras.
This is not a right angle triangle.
Cosine.
Cosine rule. You notice that you have the 2 sides and the angle between? So that would be cosine. You just learned it a while ago, you know. If you pick another year, let's pick 2015. She said May, June. Let's see if it's there. And if you scroll down again, you're going to see it. Oh, it turned upside down. Wait, is it upside down?
Yes, sir.
You might have to turn on your phone because I can't turn around mine. So you might have to turn around your phone so you can see it clearly. If you scroll all the way down to here, so you can turn your phone the other way, your device, you'll see it better than I do. So this one now, there it is, right there. So you see them knot lines there? There's these knot lines. The diagram below, not drawn to scale, shows a relative position of 3 fishing boats, K, L, and M. L is on a bearing. You see the word bearing? We're going to be looking at that. So if you notice, I picked up 3 past papers a while ago, and all 3 past papers come with a bearings question. Bearings are 40. We're going to look at how to draw a 40-degree angle, 65, all of that stuff. We're going to look at all of that in our next class. Okay? All right, so brace yourself for that. Please go ahead and rewatch the tutorial, the recording if you need to, or you can just watch a shorter version for the video. It's in my trig playlist, and make sure so you are familiarize yourself with the cosine and the sine rule when and where it's applied. Okay?
Sir?
Yes, go ahead.
Sir, for that question that you have on the screen, would we use the cosine rule, seeing that there's no angle there?
Well, it depends on what they want you to find. They said, because I think one of the questions is that on the diagram, you must show the bearing of 40. So you would have, there's some information that's given at the top. We would have to transfer that information on the diagram. Then we would make a decision as to what we would use.
Okay, understood. Thank you.
Yeah. So, all right, guys, we have come to the end of the session. Please review if you need to, because next week, Monday, we're going to be going into the application of the bearings. We're going to be drawing the diagram and learning how to insert the angles on the diagram. But until then, until next time, see you guys on Wednesday. Where are we on Wednesday? What are we doing on Wednesday?
Sir, function.
Oh, we started it? Or we're going to start it?
We started it.
So we do f of x, g of x, and undefined function already?
Yes.
Okay.
I think we do the input and output. Not
Okay,
sure.
input, output, and undefined. All right.
Yes.
So we're going to be picking up on inverse, composite functions, and some other stuff. All right. So see you guys on Wednesday.
Sir, don't go yet. Let me get
Oh,
this document.
you're going to export it?
Yes.
Export and send it to the group.
Right.
All right.
Good night, sir.
All right. Have a good night, everyone. Good night.
Good night.
Night, sir.
Jens, is you finished? Okay, she's gone. All right, guys. Have a good night.